Hello, welcome to Math 1324. This is Chapter 10, Section 1, Example 7. And in this example, we want to give the domain of the following function. f of x equals 2 divided by, all divided by 100 minus x squared. Okay, so this is actually going to be giving us a second time in which we must limit our domain. And that comes from this type of function. This type of function is what we call a rational function. Now, rational functions are functions where you have p of x divided by q of x, where p of x and q of x are polynomials. Okay, and so to find the domain of a rational function, remember that anytime you're dividing, you cannot divide by zero. It's very important. Just don't divide by zero. Don't do it. And so as a result, we'd say the denominator, whatever it is, can never equal zero. That's it. It's just saying it cannot be zero. It's an inequality still, but it's just an inequality in the sense of not equal to. Okay, so it's just telling us certain points cannot be part of this. Okay, so in order to use this, we have to understand, first of all, for this rational function, the denominator is going to be 100 minus x squared. So we're going to take that 100 minus x squared and set it not equal to 0. Okay, so if we want to solve this, we can do this in a couple of different ways. These are just quadratic equations. That's all they are. If you know how to solve quadratic equations, you know how to solve this. Generally speaking, this one is actually going to be easiest to solve by getting the x squared by itself and then using the square root property, which I showed you a second ago. So to do that, I can add the x squared here, making that 100 is not equal to x squared. So that means that basically x squared is not equal to a number. And that means that x would not be equal to plus or minus the square root of 100. And ask yourself, what's the square root of 100? Well, as far as I know, that's 10. And that's going to give us x is not equal to plus or minus 10. And that's actually going to give us two separate numbers that we cannot use here. So on the number line, that means that I cannot use negative 10, and I also cannot use 10. But I can use every other number on the number line. So how do we do that? Well, notice that means I can use every number to the left of negative 10. I just can't use negative 10, so I need to exclude that. And that also means I can use every number between that negative 10 and 10. This is the place where a lot of people forget. So between the negative 10 and 10, excluding the 10 and negative 10 both. And we can also use every number to the right of 10, just not including 10. And so these are actually becoming endpoints for their respective intervals. So what I'm going to do is I'm going to say the domain is going to start at negative infinity and end at negative 10. And all that's representing is everything to the left of negative 10. Then I need to look at everything between negative 10 and 10. So negative 10 to 10. Using a union symbol. And then I need every number to the right of 10, making that 10 to infinity. Again, using a union symbol. So your domain here is going to be negative infinity to negative 10, union, negative 10 to 10, union, 10 to infinity. Now, because my math lab does some weird things, every now and then, I saw in previous chapters that it did this. If you need to, if it has curly brackets on there anywhere, if it says the set of all x such that, and it has a blank there, and then it has the curly brackets here, in that blank, all you're going to want to write down is x is not equal to negative 10, comma, x is not equal to positive 10, or something like that. If you need to, view an example or something like that. It'll show you exactly how they want that written down. But I'm fairly confident it would be something like that if they have the curly brackets. Okay, now I said that there are, in fact, two different ways of solving this because, well, frankly, it's math and you always have more than one way of solving this. Here's what we can do instead. This 100 minus x squared is actually in the form of what we call a difference of two squares. In fact, anything that's something minus something else, something minus something else, that means that, well, frankly, it's in the form of the difference of two squares. And the factorization of this is always going to be a plus b, a minus b. And so what we can do is we can take that 100 minus x squared and factor it. And factor it. You didn't hear that. Anyway. Two sets of parentheses, and notice that these are the same thing, A and B, just with one positive and one negative there. Those are what we call conjugates. That's a G there. There we go. And so with these, we have a positive and a negative. And to get these values, all we really do is just take the square root of each one of these. So in your mind, what you would think of doing is doing the square root there and the square root there. Square root of 100 is 10, so you write it there and there. Square root of x squared is x, so you write it there and there. And so at that point, because it's not equal to 0, not equal to 0, and now what we would use is the zero factor property, which means that, here, let me write that down here. For the zero factor property, what it says is, if a times b equals 0, then a equals 0 or b equals 0, or both a and b equals 0. In mathematics, when we use the word or, it's what we call an inclusive or. So both can be 0 in that case, unless we're specifically stating it's not an inclusive or. Anyway, what that means is that we could then set each one of these equal to, well, technically not equal to 0, and we would get this, 10 plus x not equal to 0, 10 minus x not equal to 0. Subtract the 10, so x is not equal to negative 10. Subtract the 10, divide by negative 1, that means that x is not equal to positive 10. So x can't be negative 10, x can't be positive 10, which is exactly what we got here. And that's exactly what we got here and here. It's just all the same thing. It's just a different way of doing it. It depends on which way you like. Some people are going to like the square root property. Some people are going to like the factoring. It's all up to you. Alrighty. I'm going to go ahead and end it there because once we have this point, or once we have it to this point, we just go here and there's your solution. Okay, I'll see you all in the next video. Have fun.